Hello, this is Isareke Pracha. Here with yet another video regarding A-level past papers, and we are doing February March 2022 paper 1 question number 2. So in this question, a curve has equation y is equal to x square plus 2cx is equal to 4, and a straight line with equation y is equal to 4x plus c. They both are intersecting each other where c is a constant, and you have to find the set of values for c for which the curve and line intersect at two distinct points. So two distinct point means that this line and the curve are intersecting at two different places. Okay, so first of all, what we can do over here is merge these two equations to find a set of value for x. So it becomes x square plus 2cx plus 4 is equal to 4x plus c. Okay, now when we solve this will become a quadratic equation. X square plus 2, or what we can do over here, just put a bracket 2c minus 4 and take x common over here, plus 4 minus c is equal to 0. So what we did over here, we brought this whole side over here, and now solving this equation, okay, now what we have to do next is, we know that these two lines intersect at two different points, two distinct points. You know what that means? That means if we are considering it as a quadratic equation, so just writing the general form of the quadratic equation, ax square plus bx plus c is equal to 0. So the coefficient of this x square is a, which is 1 obviously, and the coefficient of x over here, yeah, that means 2c minus 4 is b, and c is equal to 4 minus c. Now this c is different from this c, obviously. You must understand this thing. Now what happens next, that we know that line of intersection, this intersecting points are two and distinct. That means they are different. So that means b square minus 4ac must be greater than 0, and we all know why is this, because if b square minus 4ac is equal to 0, that means the solution is real, but 1. The solution is real and 1. We all know that. Okay, we have studied it already. And 1. And if it is greater than 0, that means the solution is real. The solution is real, and there are two solutions basically. So that is why b square minus 4ac must be greater than 0. So this means, what is b over here? B is 2c minus 4. So 2c minus 4 square minus 4 times the coefficient of the value of a is 1 over here, and the value of c is 4 minus c. So this is all greater than equal to, sorry, greater than 0. Now solving this, it becomes 4c square, which is 2c square, 4c square minus 2 times 2c minus, sorry, 4 plus 4 square minus 4 times 4 is 16, and minus 4 multiplied by minus c is plus 4c is greater than 0. Now it become 4c square, 2 to the 4, 4 to the 4 the 16 minus 16c plus 4 square is 16 minus 16 plus 4c is greater than 0. Now, so what happens over here? 16 plus 16 minus 16 are gone. Minus 16c plus 4c is minus 12c. So 4c square minus 12c is greater than 0. Dividing both sides by 4, that means it becomes c square minus 3. 3c is greater than 0. Now again it becomes a quadratic equation basically, and we have to solve it. And what type of equation it is? The coefficient of c square is positive, that means it has shape like this, okay, and we have to find these two values where they are intersecting this x-axis, this point and this point. We have to find this. Now what happened next is we consider it as a quadratic equation, replacing greater than sign with equal to sign. So it becomes c, just do the factorization over here, taking c common, it becomes c minus 3 is equal to 0. Why is equal to 0? Because we have to treat it like the quadratic equation, not inequality. In only that way we can find the real roots. So c is equal to 0 or c is equal to 3, because c minus 3 and adding 3 on both sides, so it becomes c is equal to 3. So in order to have this greater than sign, now this is the key point over here. We cannot write it like this, that c is greater than 0 and less than 3. Okay, most of the students do this mistake. They mention c is greater than 0 and c is less than 3. This is wrong. This is wrong. Okay, why it is wrong? You can easily see that if this value needs to be greater than 0, then so over here it is 0 and it is 3. If this value needs to be greater than 0, then c must be less than 0 So it should be on this side. It has to be like this. Okay, so now what is the answer? The inequality, when we solve this inequality, it becomes C must be less than 0 and C must be greater than 3. In only this way we can have a solution with a real solution with two distinct values. A real solution. So the values for C, set of values, the set of values for C for which the curve and line intersect at two distinct points is this one. So this is the answer. This is the answer. Thanks. See you in the next video.